Hi guys, I wanted to make a video about our first lesson in our square roots and perfect squares unit. I wasn't able to finish a bit of the lesson last week with one of my classes and several people were missing. So this time I'm gonna make a lesson, a video. I'm not sure that will happen for every lesson that's missed. We'll just have to figure out ways to catch up. Sometimes that won't be this way, but for this week, I have some extra time, so I'll be able to make a video. So we're talking about squares and square roots, and something that you should have at least started to explore in grade 8. And we're gonna go a little bit further with it. So you would have seen, and we've already seen in our exponents unit, that something squared is a number times itself. And then the square root of a number is figuring out what number times itself equals that. So that's what the square root is. So we can think of the square of a number as the area of a square. Okay, so 3 by 3 is the area, right? Length times width. And we can think of the square root of a number, of the area, as equaling the side length of the square. So remember, square and square roots are inverse operations. They go back and forth with each other, just like adding and subtracting and dividing and multiplying. Squaring and square rooting are inverse or opposite operations. We have lots of different opposite operations in math, some that you've already explored and some that you will explore as you go further on in math. So what's the area of each square here? We can just take then the side length and square it to find the area of the square. Here we have 9 squared, and I want you to be writing it as squared rather than as 9 times 9, just to be used to writing things as exponents. And if a square has the side lengths of 3 kilometers, we'll get 9 kilometers squared. And then to take the square root to find the side length. So if the area of the square is 64, then the side length equals 8 millimeters. And note the difference in our units, which I know you've seen throughout your math life. That area, we get units squared, and for length, it's just a distance. So it's given just without a squared or a cubed. 20 meters. Okay. So on to really the new-ish stuff. So as you've seen through this year, we are applying some rules that we may have already seen in math to things like fractions and negative numbers. This time we're going to look at the square roots of fractions, and we're trying to find the square roots of perfect squares. So we can see that the area is given to us, and we want to see that as a product. So that's a multiplication question. The side length then as a square root would look like this. Okay, so we do a square root of the area, and then we get the side length. In fraction form here, we can just do exactly the same thing, but with a numerator and denominator. And same thing for the square root. We can write it like this, or we can write it as 2 separate ones. It doesn't matter which way you write it. Okay, you can write the one big square root sign over the whole fraction, or one on the top and the bottom. Okay, I'm not going to do all of these. This 144 is 12 by 12, so the square root of 144 equals 12. And then we can see that in the fraction. 12 times 12 over 10 by 10. And that is square root of 144 over 100 equals 12 over 10. Okay, so that's area and side length. So let's talk about what a perfect square actually is. It doesn't have anything to do with it being a square. A square is a square is a square. Okay, so if the side length is 5 or 3.25 or whatever, it always makes a square. A perfect square is a number that can be written as the product of two equal fractions. So remember what the word product means. Oops, of two equal fractions. Okay, so we could break it down into two fractions multiplied by itself. So if I go back up here, I could make this to be 8 over 10 times 8 over 10. Equal in this case, meaning exactly the same. Two exactly the same fractions, if I boil it down to fraction form. So we're gonna have to do some steps to figure these things out. Is each fraction underneath here a perfect square? And explain your reasoning. So the first thing we need to do is simplify. So we want to make sure it's simplified so we're looking exactly at the bare bones version of this fraction. And if we divide this by 2 on the top and the bottom, we have 4 over 9. Then we want to think about our perfect squares that, if you were in class, we started listing and we colored a chart full of them. So we have 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. These are our perfect squares. We have integers squared that equal them. 5 squared, 25. So you can see there's a lot of numbers in between 2 and 3, 5, 6, 7, 8. 10, 11, 12. Those numbers all in between are not perfect squares. If we look at this fraction, we'll find that the numerator and the denominator are both perfect squares. And so because the numerator and denominator both are, we say, yes, this is a perfect square. When I take the square root of it, I get these nice integer numbers. Integers just means whole numbers. And I can multiply those by themselves, two of the exact same fractions by themselves, by itself, to equal 4/9. Okay? When we look at B, we go, yeah, 16. I recognize that that is a perfect square, but 5 is not, right? So I can go 4 times 4. But when I get to a numerator, I can't find a number that multiplies by itself, the exact same number, to get 5. I could go 1 and 5, but that doesn't make these two of the exact same fractions multiplied by itself. So it has to be both the numerator and denominator to make it a perfect square. So not a perfect square in B. And in C, it's kind of similar. I can see it is simplified. The bottom number, our denominator, is a perfect square, but our numerator is not. So it's not a perfect square. So first step is just to simplify the fraction. Our second step then is to, hopefully you can see that, check that both the numerator and denominator
Jessica Jones, please ring in to the 1112 office.
Are perfect squares. So that's fractions. Let's take a look at decimals. Oh, wrong page. There we go. So we need to be able to also identify that a decimal is a perfect square. Now, a decimal is a perfect square if, you can do this two ways with decimals. If the square root is a repeating or terminating decimal, okay, so that's when you check it in a calculator, or you use fraction form to check. Okay, so I would like you to use fraction form to show me that you understand it. And then it follows the same rules as the fractions, just like we just did. So how do you change a decimal into a fraction? Well, remember when you learned place value and you had these are the tenths and this row there, that's hundredths. And here we have tenths, hundredths. This is in the thousandths position. Well, we can convert that into a fraction using that. So as far as it goes, in this case it goes to the hundredths, we're going to put that over 100 and make it a fraction. Okay, then you can use your calculator for this part. Now we're going to check, is both the numerator and denominator proper fraction? Oh, wait, we need to simplify first. So let's simplify this. We can see that 25 goes into both of these. Because if it is a perfect square, it can still be simplified and work. So 625 divided by 25, oh, well, that's actually 25. So that's the square of 25. And 100 divided by 25 is 4. So if I look at those again and go, hey, can I get two nice numbers on top of each other that multiply by themselves to get this? Well, the square root of 25, that is 5. And the square root of 4 is 2. So yes, I have a number that can be multiplied by itself to get the simplified fraction. So that was a decimal that we've converted to a fraction. And when you check it on your calculator, the square root of 6.25 is 2.5. Now careful, just because we see these numbers in a row doesn't mean that it's always, those three numbers will always equal a perfect square. If I take the square root of 62.5, so moving the decimal over one place, you can see I don't get a nice terminating decimal. So that number isn't. So you have to be careful on the decimal place, and we'll get more into that next week. Let's take a look at our thousandths. So here we have 627 divided by 1,000. That's turning our decimal into a fraction. We look to simplify. I don't see anything obvious. We can't actually simplify this number any further. So we can't divide both the top and bottom by a same number. If I start taking the square roots of these numbers, the square root of 627 goes off my calculator. It's not a terminating decimal or repeating decimal. So we already know that the numerator doesn't work. So we know it's not a perfect square, but let's check the denominator anyways. And again, it's not a nice terminating decimal. So even 1,000 is not a perfect square. Therefore, this decimal is not a perfect square. Okay, so you're going to apply these rules to both fractions and decimals to determine whether or not they are perfect squares. And then quickly, the last question here, calculating the square of a square root. So calculate the numbers whose square root is. So we have a square root of a number, and we need to do the opposite to find out what number was square rooted to find that. So there was some number that we took the square root of, and when we did that, we found the square root equals 6. Well, we can then go backwards. You know how I said we have opposite operations? We can then go backwards and do the opposite operation, which is squaring. And that will give us the number whose square root is. So sometimes students get a little bit flustered with this wording, but be careful to not get overwhelmed by it. Just think, what does that mean? We've square rooted a number, and this is what we've got. We square rooted some fraction, and we got square root 3/8. Well, then we got to go backwards and square it to find out what number that was, which is 9/64. And 5/12, we can square it. It's 25/144. We just did that power rule, right? Where we know that this exponent applies to both the top and the bottom number. And same thing here, squared to find we have 49/121. Okay, that is all for this lesson. I will do this page out and I'll post the answers for it in the notes. on the classroom. If you have any questions, let me know. Hope you're doing well.